So today we will discuss about the PROMETHEE method. PROMETHEE is also another outranking method, just like electric. And in PROMETHEE also we try to outrank one alternative from the other. So now PROMETHEE, the full form of PROMETHEE is Preference Ranking Organization Method for Enrichment Evaluation. And this method was developed by Professor Jean-Pierre Brans and Professor Bertrand Mareschal in the year of 1983. So let us explain this method with an example. So our example is to buy a car. Criteria is cost and speed. And the alternatives are Mercedes, Jaguar and Toyota. These are the alternatives. And these are the criteria, cost and speed. Now here you can see that in this method, you can indicate which criteria is beneficial and which criteria is non-beneficial. In case of Electra, we do not have the scope of indicating the criteria as beneficial or non-beneficial. And as PROMETHEE is a advanced version, a modified version of Electra, so in PROMETHEE, the inventors have tried to remove the drawbacks of Electra. So, as you can see, one of the drawbacks of Electra was we cannot indicate which criteria is beneficial, which criteria is not beneficial. But here, in case of PROMETHEE, we can indicate that. Beneficial criteria means the criteria which is related proportionately with the objective of the decision. That means more the speed of car, my preference to buy that car will be more. Our objective is to buy a car, and if the speed of the car is more, then the preference of selecting that car will be more. Similarly, or not similarly, however, if cost of the car is more, my preference for that car will decrease. Because more the cost, less preference for that alternative. If I can get a car in 80 lakh rupees, I will not buy a car in 100 lakh rupees. That is the common human psychology. So here you see, more the cost of the alternative, lesser is the preference. But more the speed of the alternatives, higher is the preference. That is why speed is a beneficiary criteria or beneficial criteria, and cost is non-beneficial criteria. And here these arbitrary values are given here for the example. So the first step is to normalize the values, whatever is in the evaluation matrix, that is the earlier matrix, and the normalization is done following the feature selection method or feature normalization. Here what happens is the beneficial criteria, the values of the beneficial criteria is normalized by this formula. Max minus maximum value among the set of values, that is among the values of the alternative of the beneficial criteria, minus minimum of the values for the beneficial criteria. So suppose in case of speed, if the values are like this is an so it's like this: 50, 70, 100. So as speed is the beneficial criteria, so what we'll do to find the normalized value of this number, this value, what will be the, how we'll calculate that? Now this AI is actually the number or value which we want to normalize. So this will be our 50. Now minimum A1 to M is the total number of values in the set, and 1 is the first value. So A1 to M is, in this case, 1 is 1 to M is 1 to 3. So minimum of these three values is our 50. So this will become 50. And maximum value is 100 in this, within these three values. So 100 minus 50. So the numerator is 0 and denominator is 50. So ultimately the result is 0. Now you see the minimum value in the set, when we normalize this, it will get 0. But when I normalize the maximum value in this set, what happens? This is your 100, and in the denominator 50 will be there, because 100 minus 50, 100 is the maximum value and 50 is the minimum value. So 50 by 50 will be 1. So this will be 1, and this value will be some value in between this 0 to 1. So it itself will indicate that speed is a beneficial criteria, because its minimum value is getting the value of 0 in the normalization, and its maximum value is getting the normalized value of 1 up when we normalize the maximum value in the set. However, in case of cost, what happens is, which is a non-beneficiary criteria. So what happens is, suppose cost is like 200, 500,000. Suppose this is rupees. So this is a non-beneficial criteria. So we will use this formula, right? Formula for non-beneficial criteria. So maximum of these three set is 1000. And this is your, let us normalize this value. So AI is your this value, the value you are normalizing. So this become 200, and you divide it, and 200 is also the minimum value within this set, right? So divided by the same thing, maximum value, this is 1000, minus minimum value, this is 200. So here you see this 200 will be normalized as 1, because this is the minimum value. So it must, so this 1 will be indicative of that, because when we will do the decision making, what will happen is, we will when we are doing the decision making, what will happen is, we will use these values, these normalized values, not these values. We will use these normalized values for decision making, right? Not the real value of speed, the real value of cost. So these normalized values must indicate whether the criteria is beneficial or not. So how it can be indicated? Only if we use this formula for normalizing the beneficial criteria, right? And this formula when using the non-beneficial criteria, when normalizing the values of the non-beneficial criteria, right? So that is why you see this minimum value of non-beneficial will become 1, highest preference, and the maximum value will be 0, because if AI is the maximum value, so max this becomes the maximum value, so max will deduct, so this will, in the numerator it will be 0, in the denominator whatever it may be 800, but 0 by 800 is actually 0. So this will be our least preference, because this is the maximum value, and in case of non-beneficial criteria, maximum value alternative is always discouraged. So that is why its normalized counterpart or normalized equivalent is 0. However, the minimum value of non-beneficial criteria is always encouraged or preferred. So that is why normalized output of this non-beneficial criteria will be 1, or the maximum value in the within the normalized value. So this is the way you normalize the values of the alternatives of both the non-beneficial criteria cost and speed, the beneficial criteria. Next is finding the evaluative difference. What is that? Let us see. So evaluative difference, which is indicated by D, is nothing but you deduct one alternative from the other, right? You deduct one alternative from the other. So here there is Maruti, Jaguar and Toyota. So you deduct value of cost for Maruti, deduct the cost of Jaguar from Maruti, the normalized cost of Jaguar from Maruti. Here it is, right? So this value of Maruti is deducted, or this value of Jaguar is deducted from this value, 1 minus 0.5. 1 minus 0.5. Same for the speed criteria. This value, so this value of Jaguar is deducted from this value of 0. So 0 minus 1, right? So this is for m minus j. As I have said, always maintain the sequence. M minus j, then m minus t. After that j minus m, j minus t, then t minus m, t minus j. So just deduct the value of one alternative from the other, the normalized value of one alternative from the other, for both the criteria, for both cost and speed. Right? I think this is self-explanatory. So we move to the next slide. So what is this? Now, what is preference function? How we apply preference function? Now what happens is, here whichever value is here, if the value of d, okay, if the value of d is less than or equal to 0, then your preference, the value of your preference function will be 0. Otherwise, it will be replaced by these values that you have calculated in the earlier matrix. Right? You see, 1 minus 0.5 is 0.5. So more than 0. That is why we write, in case of preference matrix, we write it as it is. However, as this value is negative, it is a negative value, less than 0 value. So that is why we have replaced it with 0. Next is, in case of m minus t, this is 1, more than 0, write it. This is minus 0.5. So less than 0, do not write it, use 0. Here in case of j minus n, this is negative, write 0. This is positive, write the number as it is. In case of j minus t, this is positive, this is positive. Write both the number as it is. In here, this is negative, write 0. This is positive, write the number as it is. This is negative, write 0. This is negative, write 0. So thus you create the preference matrix from the evaluative matrix. Okay. Now the next step is to create the aggregate preference function or aggregate preference matrix, and how it is done. Yes. So how to do it? Here we have to use the weightage of criteria. Here also the same thing, same drawback like electron. You have to, the decision maker will assign the weight of criteria, right? So this is also a drawback of PROMETHEE as it is a drawback of electron. So what we do is we multiply the weightage of criteria with the value we get in the preference matrix, that is the earlier matrix. You see in the earlier matrix, m minus j was 0.5. So we just multiply the weightage of the criteria cost with that preference value. So there was 0.5 and we multiply it with the weight of cost 0.6, right? So it becomes 0.3. And in case of speed for m minus j it was 0 as it was a negative number. So that is why we just multiply the weight 0.4 weight of criteria with the value preference value. But as the preference value was 0, so this becomes 0. So after then what we do? We just sum both of these values. So we sum this one with this one. So we get what? 0.3 plus 0, it is 0.3. Similarly, in case of m minus t, it was 1. The preference value was 1. So that is what we have done. We have multiplied the weightage with the preference value. So 0.6. And in this case also the preference value was 0. So this becomes 0. So when we add these two, we get the value 0.6. So in similar manner, here this preference value was 0. So this becomes 0. Here the preference value was 1. So this becomes 0.4. 0 plus 0.4 is 0.4. Then this one, same thing. Then you add it. Here also you add it. Here also you add it. And by adding, you will get the aggregate preference function. Actually, these are all your preference values for this criteria and with respect to the m minus j, m minus t, j minus m, j minus t, t minus m, t minus j. And when you aggregate it by multiplying the weightage of the criteria with the preference value and adding with the product of weightage of criteria with the preference value of that criteria, you will get the aggregate preference function, right? Now after getting the aggregate preference function, now you will create the alternative pairwise comparison matrix, right? So how you create it? mj, first m and m, yes, nothing done, nothing jj, nothing done, tt, nothing done. But however, mj, m minus j, what is the aggregate preference function? This is 0.3, m minus j. So this is placed here. M minus j, this is 0.3. Then m minus t, this is 0.6, place it here. J minus m, what is that? J minus m is 0.4, so it is placed here. Then J minus T is 0.5 placed here. T minus M, aggregate preference function is 0.2. We have placed it. T minus J was 0. So T minus J is 0. So we convert this aggregate preference matrix into a M and M alternative pairwise comparison matrix. Now is the very important step in this method, leaving and entering outranking flow. This is also the name may be very complex, but it is not very complex. What happens is when you average the row of the aggregate that alternative pairwise comparison matrix that we have developed in the earlier step. When you average the values of that, the row values of that matrix, you get the leaving flow. And when you average the column values of the matrix, that same matrix, you get the entering flow. Here I have already written that average of column values and average of row values. So when you average the row, you get the leaving flow. When you average the column, you get the entering flow. So you do it for each row and each column of that AAPCF. That means this matrix. Now, application of net outranking flow to rank the alternatives, very easy. So for M, you see, the leaving flow is 0.45, right? And the entering flow is 0.30. So here, the leaving flow of all the alternatives is placed, and here in the entering flow column, the entering flow of all the alternatives were placed. Now what you do is, you deduct the entering flow from the leaving flow. That means 0.45 minus 0.30, 0.45 minus 0.15, 0.10 minus 0.55. Now based on this, you see, you find the maximum value. Here it is 0.30. In case, remember, in case of net outranking flow, sign is very important, and we consider the impact of sign while selecting the maximum value. Here, although this negative number 0.45, if I take the magnitude, it is the maximum number. But as we consider all the values with the sign, that is why this positive number 0.30 become the highest value within these three values, and that is why this Jaguar alternative, Jaguar becomes the most preferred alternative among these three alternatives, followed by the next highest positive value, that is of Maruti, and lastly this is the negative value, so naturally it will get the least preferred, least choice or least preferred selection, which is your torque. So while comparing the net outranking flow of all the alternatives, consider the sign. So if there is any negative number in the net outranking flow, they cannot overtake the positive number. Here the values are considered along with the sign. The absolute value or only the magnitude. In case of net outranking flow, it is not considered. Here the values are considered with its sign. So any negative number cannot outrank any positive number. Okay, even if the magnitude of that negative number is more than the positive number. So this is the way we select the best alternative in case of PROMETHEE II. But in case of PROMETHEE I, the older version, this is the newer version, PROMETHEE II. But in case of the older version, what happened is we calculate the leaving flow and entering flow by adding the value of that aggregate preference function. So instead of averaging, what we do is we add it. Add the row values, add the column values, and we get the leaving flow from the summation of row values and the entering flow from the summation of column values. Now the next question is how to select the best alternative with the help of PROMETHEE I, the older version of PROMETHEE. So let us see how we can do it. Okay, so these are all our leaving flow found out by the summation of your row values, and these are all the entering flow which was found from the summation of the column values, right? In case of the later version from the 2, we have averaged, but in case of this, the older version, we have summed. So after finding this leaving and entering flow, to select the most preferred alternative, we have to follow some conditions. What are the conditions? Leaving flow of the alternative AI is higher than the leaving flow of alternative AI minus 1, and entering flow of alternative AI is lower than the entering flow of AI minus 1. Or there are two more conditions. Okay. So let us explain it with an example. Okay. And there are some condition of indifference and also condition of incomparable situation. Okay. Now what are they? What are the condition of selection? What are the condition of indifference? That means nothing can be selected. What are the condition of incomparable? So let us see how it is done. You see, in case of m minus j, the leaving flow of m, the alternative m, minus the leaving flow of alternative j, right? And here it is the entering flow of m minus the entering flow of j. Our decision is that this comparison is incomparable. Why? Now the condition for selection is when you can select the best alternative out of two. The condition that we must satisfy is that the leaving flow will be positive, entering flow will be negative when the leaving flow of one alternative is deducted from the leaving flow of the other alternatives. And follow the sequence, don't change the sequence. M minus j, M minus d, j minus n, j minus d, t minus n, t minus j. Don't change the sequence. That means if you have three alternatives, A1, A2, A3, then A1 minus A2 will be there, A1 minus A3 will be there. Now A1 complete. Then you go to A2. A2 minus A1 will be there. A2 minus A3 will be there. So A2 complete. Now A3 minus A1 will be there. And A3 minus A2 will be there. That is why all the alternatives is completed. So always follow this sequence. Don't change the sequence of alternative. 1, 2, 3 will remain as 1, 2, 3. Otherwise, this thing will be erroneous. Now, what happens is when I deduct the leaving flow from of one alternative from the leaving flow of the other alternative, what happens is if this leaving flow, the result of this deduction of leaving flows is positive, and the result of the deduction of entering flow is negative, then you can say M is more preferred than T, as we are deducting the T from A. When this situation arises, you can say M is more preferred than T. That means the deduction of leaving flows is positive. However, the deduction of entering flow is negative. Okay. Again, if you see this is the same place here, the leaving flows are both are same. So that is why this is 0. Leaving flow of J and leaving flow of M are same. So that is why this is 0. However, the entering flow is less than 0. That is negative. In this case also, you can say that J, that is the alternative from which the leaving flow of another alternative or entering flow of another alternative is being deducted, is preferred over F. That means the alternative which is being deducted from the other alternatives. So always remember, if this is the case, then also we can straight away select the best alternative among these two, right? Again, if this is the same case, this is positive, this is negative, so you can say that J is preferred over T. However, if the case is reverse, that means leaving flow is negative, the deduction of leaving flow is negative, and entering flow is positive. This is positive, this is negative. You cannot compare that. You cannot say T is more preferred than M. Okay? So you see, for these two situations, here the leaving flow is negative and entering flow is positive. So this will become your incomparable. But, and now you say that when the alternatives become indifferent, they are neither comparable nor incomparable. When the deduction of leaving flows and deduction of entering flows both are 0. That means they are equal. Leaving flow is equal, entering flow is also equal. Then only you will say that both are indifferent. Both the alternatives are indifferent. So you cannot make a decision. But when you can compare, as I say, leaving flow, that means deduction of leaving flow and deduction of entering flow. This you must remember that this is deduction, okay? This is deduction, not the leaving flow, entering flow. So in case of leaving flow and entering flow, what happens? If deduction is positive and this is negative, comparable. This is 0, this is negative, comparable. This is positive, this is 0, of course comparable, right? Here what we see, we see the example of these two. You see, this is 0, this is negative, we compared. This is positive, this is negative, we compared. This is positive, this is negative, we compared. However, if this reversed, the deduction of leaving flow and the deduction of entering flow, if the leaving flow deductions are negative and entering flow deductions are positive, then you cannot compare those two alternatives whose deduction of leaving flow is negative and the deduction of entering flow is positive. You cannot compare those. And there is another situation that may arise. This may arise like this, that leaving flow is 0, but entering flow is positive. Then also we cannot compare. Right? So leaving flow must always be positive and entering flow must always be negative. It can be 0. If leaving flow is 0, entering flow must be negative. If leaving flow is positive, entering flow must be 0. Then we can compare those two alternatives. We can say that A1 is better than A2 for all these cases. But if the case is like this, leaving flow become minus, deduction of leaving flow, and deduction of entering flow become positive, then we cannot compare. Even if leaving flow become, deduction of leaving flow becomes 0 and the entering flow become plus, then also we cannot compare. If entering flow is minus and leaving flow is 0, then we can compare. This is the situation. But if it is plus, entering flow is deduction of entering flow is plus, and the leaving flow is 0, then we cannot compare. And when the deduction of leaving flow and entering flow both are 0, then these two alternative becomes indifference. Indifferent. Okay, so neither comparable nor incomparable, only indifference. Indifferent. You cannot say these can be comparable. You cannot say this cannot be comparable. No. But you can say that it is indifferent. Both these alternatives are indifferent to each other. And remember, in case of PROMETHEE, all these are deductions. Don't forget that. These are all our deduction. Deduction of leaving flow, deduction of entering flow. Okay. So when deduction of leaving flow is plus, entering flow is deduction of entering flow is minus, comparable, 0 minus comparable, plus 0 comparable. However, when leaving flow is minus and entering flow is positive, the moment the entering flow become deduction of entering flow become positive, you cannot compare those two alternatives. Okay, and if both deduction of leaving flow is 0, deduction of entering flow is 0, then both the alternatives are indifferent to each other, no relation, nothing. More or less, this is your PROMETHEE 1, and you can see from both the method, PROMETHEE 2 and PROMETHEE 1, PROMETHEE 2 is better. I do not, better. It is short, but it is to the point. In that case, you just deduct entering flow from leaving flow. You get the values. The maximum value among all these deductions will give you the the best alternative. And you have to consider the sign, impact of sign. Whenever no negative value can outrank the positive value. Okay, that's all. But in case of PROMETHEE 1, you see, you have to remember all these conditions. And in there are total 3 conditions of comparability, 1 condition of indifference, and 2 conditions of incomparability. So all these 6 conditions you must remember to find a solution from the PROMETHEE 1.